Welcome to CSEGuru. In this session, we will discuss the subject data structures and applications. In that topic is operations on a linked list. Already, we have discussed array implementation of stack and its operations. We have seen examples as well as the C program to implement array implementation of a stack. Now, we are going to discuss the different operations performed by stack using linked list. There are three basic operations stack supports: push operation, pop and peek operation. Push operation is used to add or insert an element at the top of the stack, and pop operation is used to remove or delete an element from the top of the stack, and peek operation, it will return the value of the topmost element of the stack. So all these operations, if you are considering in stack, everything will happen at the top position of the stack. Suppose if you want to insert an element, in the sense, insertion will happen at the top of the stack. If you are placing 5, next 10, next 15, in the sense, this will represent the top position. The top element, the new element what you are adding, that will represent the top position. Suppose if you want to add one more element, 20, now this 20 will represent the top position, not 15. Suppose if you want to delete it, in the sense, if you want to remove an element from the stack also, the top element only will be removed. What is the element you have pushed last, that is recently into the stack, that will be removed first. The first element what you have placed, that will be removed at last, because it will be placed at the bottom of the stack. So insertion as well as deletion both will happen at the top of the stack, and a peek operation, just it will return the topmost element of the stack. What is the top position element? Just it will return. So these are all the three basic operations we can able to implement both in array representation as well as in linked list representation. The linked list representation of a stack is otherwise called linked stack. Okay. First, push operation, that is insert operation. Push operation is used to insert an element into the stack. The insertion operation we can able to implement in stack, that is called push operation. The new element will be inserted at the topmost position of the stack. Always insertion will happen at the top position of the stack. So whenever you are adding new element, that will be inserted at the topmost position. So before implementing insertion, that is push operation, first you have to check whether top is equal to null. Meaning is top is empty. That is, there is no data in the stack. You are going to create a new stack with linked list implementation. That is the meaning. Okay. So here you have to check top is equal to null. If so, allocate memory for a new node. So top is null in the sense, allocate memory for a new node, store the value in data part and null in the next part. For example, if I am creating a new node, here top is equal to null. Okay. So allocate memory for new node. So new node you have to allocate. This is a linked list representation. Always linked list will consist of two parts. One is the data part and another one is the next part. Next part will store the address of the next element. Suppose if it is the first element in the sense, top is null. If it is the first element in the sense, store the value in the data part. For example, 5 I am storing in the sense, store the value in the data part and null in the next part. That is for the first element. Okay. So null in the next part. And this new node will be called as top now. There is no element in the stack. This is the element first you are going to insert into the stack. So here place the value in the data part and null in the next part. Suppose if top is not is equal to null, that is already there is an element in the stack. Okay, top is not equal to null. Then insert new node at the beginning of the linked list. So here what happens, suppose if I want to insert another node in the sense, this is the new node I want to insert 10. Okay. So now insert new node, place the value in the data part and the next part you have to store the address of the next element. Okay, this address will be stored here. Now top will be represented by the newly inserted element. This is the top now. Suppose if I want to insert one more element here, 15 in the sense, value in the data part and the next pointer you have to place it in the next part. And now this is the top. Suppose if you want to insert a new element, allocate space for the new node, okay, and then this will be called as top. This new node what you have inserted, new node is called as top. This is called insertion. Only for first element you have to check whether top is equal to null. If top is not null in the sense, meaning is already there is an element in the stack. So automatically you can able to create a new node and insert at the top position of the linked stack. So this is called insertion or push operation in linked stack. So algorithm if you are considering in the sense, step 1, allocate memory for the new node and name it as new node. This new node will be called as new node 1. Set new node of data is equal to value. What is the value you want to place it? Place the value in the data part, new node of data. Okay, so for example, here this is the new node in the sense, okay, new node you have created and place the value in the new node of data. This is new node, this is the data part, this is the next part. And value you have to place it here. If top value is null in the sense, meaning is there is no element in the stack. This new node is the first element in the stack. So in that case, new node of next is equal to null. New node of next, you have to place it as null. Suppose if this condition is false, meaning is already there is an element in the stack. In that case, what we have to do? Set new node of next is equal to top. This new node of next, you have to make it, this will be considered as top. Okay, and set top is equal to new node, and this new node will be the top now. So this is the algorithm to implement push operation in linked stack. And one more thing in insertion, why we are not checking overflow message here? Here we are not checking the condition whether stack is full or not, because whenever it is required, you can able to allocate memory for new node and you can place the data. How many elements you want, there is no restriction. You can able to insert into the linked stack. Allocate space for new node, then place the data. That's it. So here no need to check whether stack is full, no need to display overflow. Next, pop operation in linked stack. Pop operation is used to delete the topmost element from the stack. So insertion as well as deletion both will happen at the topmost position of the stack. The pop operation will delete the topmost element from the stack. So before deleting, we have to check whether top is equal to null. Top is null in the sense there is no elements in the stack. Then we cannot able to delete an element. There is no element. Okay. So if so, stack is empty, cannot able to delete if top is equal to null. Suppose if the condition fails, if top not is equal to null in the sense, delete the topmost element from the stack. So if top is null in the sense, it will result in underflow message. Cannot able to delete an element from the stack. For example, this is the linked stack and this is the top position. Suppose if you want to implement delete operation in the sense, the topmost element will be deleted. So if you are implementing delete operation, this element will be deleted. Now the linked stack will be 20, 28 and 30 will be there. The element 15 will be deleted. Now top will point here, element 20. After deleting 15, top now it will be replaced with the element 20. Okay. So this is pop operation. Algorithm if you are considering, if top is equal to null in the sense stack is empty, it will display underflow message. And go to step 5 comes to an end because we cannot able to implement delete operation, right? Otherwise, if this condition fails in the sense, step 2, set pointer is equal to top. Okay, so this element we want to delete. So pointer is equal to top. This is the top element and this you are naming it as pointer. And set top is equal to top of next. Top is equal to top of next. So top of next is 20. This will be represented as top now. Okay. And then free PTR. Free this PTR. That's it. We have popped the element from the stack. This is linked stack before deletion and this is linked stack after deletion. Next is peek operation. Peek operation is used to display the topmost element of the stack. What is the content of the topmost element in the stack? Content or the value of the topmost element, it will display. That is peek operation. So before implementing peek operation, we have to check whether top is equal to null. If top is null in the sense, stack is empty. So with empty stack, there is no contents. Okay, so you cannot able to display the top element of the stack if top is equal to null. Suppose if top is not equal to null, condition fails. Meaning is there is already elements in the stack. If elements are there in the stack, we can able to implement peek operation and it will display the top element of the stack. If stack is empty, in the sense, it will also display underflow message. Okay, if stack is empty, there is no element in the stack. Otherwise, it will display the top element of the stack. For example, we are considering this as a linked stack, and here the algorithm first it will check whether top is equal to null. If top is null, this is top position. Okay, so here algorithm first it will check whether top is equal to null. No, in the top element is there. Okay, so condition fails. It won't display this message. It will go to step 2. It will return the top position of the stack. So in the top data part, this is the data part. So top of data, what is the value? It will display 20. Okay, it will display 20 and it will come to an end. Suppose if top is equal to null, in the sense there is no element in the stack, it will display underflow message. There is no element in the stack. That is the meaning. Okay. Otherwise, it will return the top element of the stack. In the topmost position, what is the value? Just it will display. That is peak operation. So this is all about all three basic operations, how we can able to implement with linked stack. In the next session, we will discuss a C program to implement linked stack. Thank you for watching this video.